Next, we talk about acrylic based adhesives. Now, if I want specific improved adhesion for my substrate, or let's say there are certain coatings and there are certain adhesives which I apply on the substrate, but yes, with the exposure of the sunlight they become pale yellow or yellowish, and I do not want that to happen. So I have to go for acrylic based adhesives. So in other words, we can say that the acrylic based adhesives are usually employed where improved specific adhesion is required, where or rather resistance to yellowing from exposure to ultraviolet radiations is required. Now acrylic based adhesives are used in three main areas. What are those areas? Number one, heat sealable adhesives. Laminating adhesives is the second, and the pressure sensitive adhesives is the first. Let's talk about the heat sealable adhesives. Now, as the name suggests, heat sealable adhesives, the adhesives which seal the surface wherein the heat is applied. Okay, so heat sealing is used for bonding the two substrate when one or both are the substrates are impervious to water. They do not allow water to pass through it. Typically what happens, the more heat and solvent resistant a substrate is coated first, the solvent is let's say we the substrate with the coating which is to provide a solvent resistant surface or more heat resistant surface. So what happens, basically the solvent which is used, whether it is water or an organic solvent, is driven off in an oven when you apply heat. At this point, what happens, the web can be wound up on itself. If the dried adhesive is let's say not sticky or non-blocking, the heat sealed to the secondary substrate at a later date. Alternatively, what happens, the adhesive coated substrate can be laminated simultaneously to the second substrate that we'll study in the laminating adhesives. So when the heat is applied, it is done, basically it functions to soften the adhesive. The heat applied functions or works to soften the adhesive. It makes the adhesive soften and activates it for the strong bonding. And at this particular situation, there are two conditions which must be met if we want an adequate bonding with the substrate, if we want sufficient or the required amount of bonding or of adhesive to the substrate. What are those two conditions? Number one, the adhesive should have sufficient flow. It should be easy flowing, not too much, but yes, easy flowing at the activation temperature, at the temperature at which I am working, at the temperature which is subjected to that particular adhesive, so that it can properly wet out to the secondary substrate. It can make the second substrate also wet. Then only, of course, there will be a bonding between the two substrates. So that is the first condition. Okay, sufficient amount of flow, sufficient level of flow at the activation temperature, so that it is capable of wetting out the secondary substrate. Condition number two, it should have a chemical affinity or a specific addition to the particular substance. Only the physical interaction is not sufficient to make the adhesive strongly binded to the substrate. Only the physical interaction is not sufficient to bind the two substrates together. So it should have a chemical affinity or specific addition to the specific surface, to the particular substrate which is it is applied on. This comprises the secondary chemical bonding forces which basically give rise to the adhesive bonding. The areas, the applications, the articles wherein such type of adhesives are used, it is in food packaging. It is like, for example, the lidding type adhesives for coffee creamers, and for jams and jellies we use such type of adhesives. In short, food packaging. Another one, yes, very important, and you can notice it in your daily life also, the pharmaceutical, the blister packaging of pharmaceuticals. There are tablets and there are capsules in the strip in that strip of medicine. So how is it physically visible? There are tablets, and besides the areas wherein there are no tablets, all the two surfaces, the two layers of the packaging are binded together. So there, that is called as the shining surface, it's called as a blister packaging. Anyway, so the heat sealable adhesives are used over there. They are sealed with the help of heat. Second is your laminating adhesives. Now, laminating adhesive, they function in a similar way, almost like the heat sealable adhesive, but there is a one difference, major difference between the two. Adhesives, they can be designed to function anywhere between the room temperature and 90 degrees centigrade. So 90 degrees centigrade is the higher limit for the laminating adhesives, but yes, they can be functional at room temperature also. Recently, there are many low temperature curing types of adhesives which are being developed. These are the new adhesives to an extent which have replaced the two component solvent adhesives wherein polyurethane was used in flexible packaging area. Designing a room temperature curing mechanism into an acrylate system, progress is further going on, which actually is promising to further enhance the opportunities to replace the solvent system. So we are using the acrylate system, we are doing work on the acrylate system due for the curing at room temperature. That will be very promising if we want to replace the solvent system. So considerable progress has been made in these areas, curing of acrylics in the industrial area. The typical applications for the laminating adhesives, it include vinyl to wood laminating, vinyl to ABS lamination for automotive interiors, the interiors of cars, the dashboard that you have in cars. So all these places, the laminating adhesives are used. Number 3 is the pressure sensitive adhesives, which is also called as one-way bonding method. In this case, the adhesive is coated on the substrate either directly or let's say by the transfer coating. You apply on one substrate and you put on the other surface, it gets transferred. So the adhesive is protected by a release liner. What's a release liner? Like example, for in a two double-sided tape, what you have, the rim of the double-sided tape, the wheel of the double-sided tape, it has a paper covering over the entire surface of the tape. So that is a liner, we say. So we release the liner. We do not release the liner if you don't want to use it. We release the liner when we want to use it, and then it is sticky, it is adhesive. So when application is required, the liner is removed and the adhesive coated substrate is bonded to the other substrate using the pressure alone. You have seen that a double-sided tape, whenever you apply on a surface, you apply some pressure with your palm so that it can stick well, and then you are assured, okay, fine, it won't go off now easily, it won't delaminate now. So pressure actually activates the adhesive, hence the name of this method. The adhesive which is used in that tape, the pressure is activating that adhesive. The more pressure you apply, the better it will be bonded to the surface. Upon firm pressure, the sticky adhesive mass, the tacky adhesive mass actually flows and bonds itself mechanically as well as chemically to the other substrate. But yes, to be functional, a pressure sensitive adhesive should be more than just very tacky. It should not be only tacky, it should have high cohesiveness, it should have high internal strength. So a functional pressure sensitive material will have high tag or high adhesive strength combined with other cohesive strength, the basis requirement for any adhesive. So the pressure sensitive adhesives are used in many tape areas such as packaging, masking, electrical mending, medical, mounting, and so on. These areas generally require an outstanding balance of properties that must be retained under severe outdoor exposure and temperature extremes. So such properties actually such as the outstanding resistance to ultraviolet light degradation, plasticizer migration, these are also required for a good adhesive. So adhesive for this area must produce clear, colorless film, dictating the use of acrylics exclusively. That is the major USP. Usually the solvent-based polystyrene acrylics have been used traditionally in most of these areas, but most recently they have been replaced up to an extent with their emulsion counterparts. But yes, of course, still a technical areas, lacunae are there in which the solvent systems still are the winners, they are prevailing. and these includes the applications requiring high levels of heat, water, solvent resistance. So that's about the pressure sensitive adhesives, and a little bit of the story of the acrylic based adhesives. Now try to trace out the from your daily life, fix a 1 week to of your schedule. Take 1 week and daily you just come across any type of adhesive that you are using, any type of adhesive which is being used around you by maybe by some other person, any type of adhesive which you come across through an article. If you buy let's say if you buy something from the market and you see that okay, the surfaces are sticking together or an adhesive has been used in this particular article, just list it down, take it down, note it down, and try to search about it. What type of adhesive is it? Is it a heat sealable acrylic adhesive? Is it a laminating or a pressure sensitive adhesive? I'm sure that's going to give you a spark in your daily life activities,